work done, power, and energy. So we are starting with the energy. Okay, so energy possessed of the body to do work. Okay, state the principle of the conservation can neither be created nor destroyed. Fundamental line you're required to memorize. Energy can neither be created nor destroyed, but can be converted from one form to another or others. All right. For suppose the kinetic energy can be converted to potential energy. The gravitational potential energy can be converted to the kinetic energy. Kinetic energy can be converted from the thermal heat energy, and so on. Understand? The total amount of energy in any closed system is called or is constant. Okay? Energy and work are both scalar quantities, hence they have the SI unit of joules. Okay, so just read the definition of work done, which is the product of a force and displacement in the direction of force. Alright, so from your O levels, it's a bit new formula for you, candidate, but that's not shocking for you as you are good in your kinematics and dynamics. It will be helping you a lot here because of only reason that there are some resolving vectors. In physics, work is done when a force moves its point of application so that some resolved part of the displacement lies along the direction of force. Now here you can see that an object have discovered a certain displacement which is represented by the letter S. Alright. F represents the force which is not parallel to the line of displacement. If it is parallel in this case, in this diagram, if the force is parallel uh, to the arrow of displacement, then we can say that F is equals to W is equals to Fs. Work done is equals to force multiplied by distance. Alright, but in this case, can you just determine it easily? I mean, you are required to focus on resolving vectors. Yes. Alright, so in this case, you are required to resolve the vectors. Here, as define work, okay, so we have already defined the work. It is a force, it is a product of force and displacement within the direction of force. Within the direction of force is very important word for you. So here's the formula: W is equals to Fs cos theta. Understand? Here the W is the work done, which is measured in joules. F is the constant force acting on the object, which is measured in Newton, or if you are best in your kinematics, you know more better the SI base unit. For S is displacement and theta is the basically angle or whatever. We are required to just write it as degree simple. In cases where no angle is given, you may use the equation W is equal to work done is equals to force multiplied by displacement, which is in meters. Alright? Okay. You must know how to derive the formula. Unit of work for work is joule. 1 joule is defined as a work done by a constant force of 1 Newton on an object when the object moves 1 meter in the direction of force. Or in equation, we are required to describe as 1 joule is equals to 1 Newton multiplied by 1 meter is equals to 1 Newton meter. Alright. The unit Newton meter and m is usually used for moment, while joules J is usually used for work. Okay. Alright, so there are some scenarios which you are required to recognize and the work done on object in that scenario particularly, and the example may help you a lot. Okay, so in the scenario, for suppose force does not move the object. Okay, so if the force does not, the force is the force obviously is applying, but the mass of the object is more than the force applied, so it is very complicated to just push the heavy mass. Although we are applying the force, the object is not moving, so the work done is on the object is zero. There is no work done due to the reason that it is not moving, it is not traveling to a certain displacement. Yes. All right, so if the displacement is zero, and for suppose I am just applying the force of 50 newton or maybe 100 newton, so 100 or 50 or whatever the value is multiplied by 0 due to the reason that the displacement is 0, it's not moving. Okay, so then Wait a minute. All right, so where were we? Yeah, we were talking about the force that, for suppose if the heavier object but it's not moving, so its displacement is obviously zero. So whatever the value of force will be multiplied by zero is equals to zero, means no work done. Force is perpendicular to the object's motion or movement. Okay, whatever. Force is perpendicular to the object's movement. It means that the work done is still zero. You can see, okay, so for the example, for force does not move by the object, so the work done is zero. The example is a man pushing a wall. Obviously, a man is not have a greater mass than wall, and wall have a greater mass, so due to this reason, it's not moving and it's very difficult to move. Okay, so from the force is perpendicular to the object's movement is that we can say that weight of a trolley moving along a horizontal surface. Okay, it means that the weight of a trolley moving along a horizontal surface. So it means that there is no work done. Okay. Force has a resolved power in the same direction as the object's displacement. What does it mean? And the force has a resolved power in the same direction as the object's displacement. Oh, so there must be the positive work done, such as a man pushing a trolley. It will be moving towards the positive direction. All right. Yeah, but if we are talking about the negative, it means that there is a friction opposing the trolley's motion. And what is the friction? Friction is the opposing force. Or if I'm applying the force to an object at the right side, so there must be the force of friction at the left side, which is opposing the motion of the object. Here, motion of the trolley. Direction as the object's movement, sorry, displacement. All right, so then the work done must be negative. Remember this. If there must be friction and all right, while if the object is moving towards the direction where I am applying the force, so it means that it is having a positive work done. Note, even though work is a scalar, it can be positive or negative. In the above examples, positive work done on an object increase the kinetic energy of the trolley, while negative work done decrease its kinetic energy. Zero work done means kinetic energy remains constant. Okay. When we are increasing the work done, sorry, when we are doing the work done in the direction of force. All right. So the work done is always positive and will increase the kinetic energy. Because of the increase of the kinetic energy, this is one of the reasons due to which the trolley will start moving. All right. And when we are supplying the force, but there must be the frictional force, and which is opposing the resultant force. So then what we can say is basically that the kinetic energy decreases due to the only reason that the work done is negative. And decreases kinetic energy always means that the work of what is the work of the friction? Work of friction is to stop an object. It means it's opposing force. Okay? So it will obviously it will be becoming slower and the work done is negative. And zero work done means kinetic energy remains constant. No effect. Alright? Work done by a force. Sample problem 1. Now see here, the following are examples of work done by a constant force. Work done by the man on a box. Okay. See figure 6.3. In figure 6.3, there is a positive work. How can you tell that this is a positive? The work done is positive. How? By calculation? Yes, by calculation. F is equals to, sorry, W is equals to F cos theta, where the work done is equals to force multiplied by displacement multiplied by cos theta. But why you are applying cos theta? What is the reason for cosine here? This is due to the reason that you can see that the angle is mentioned here. All right. If the angle is here, this is the hint for you candidate that there must be the cosine rule applying. Not cosine rule, but the cos must be present there. All right. To find out the 10 Newton, or what we can say is that the work done. All right. 10 multiplied by 10 cause 30. Answer is 86.6, which is in two significant figures, so 87 joules. All right, it is positive. Okay. Sample to solve it. Work done by a man in opposing the sliding box. All right, sliding. Okay, so it's slowing down. It means that it is negative work done, and how do you know? By inserting the values. Okay, by the calculation. You see here simply that it is minus 50 joules. So negative 50 joules means negative work done. Whatever the value negative means negative work done. And the man is pushing this object which is slowing down. Alright, so this scenario is obviously understandable to you until and unless you just calculate the values and see whether it is negative or positive. Alright, when it's negative, there might be friction. If it is positive, so the object is moving within the direction of force which you are applying, not the friction one. Sample problem 3, solve it. Okay. Work done by the frictional force in opposing the slide box. Alright, it is again the negative due to the reason that the friction, okay, the work done by friction is written obviously here. Figure 6.5 shows you that this object has a constant velocity and it has been covered 10 meter displacement, including the 2 Newton, which is the friction force. Alright, so here the work done is equal to friction force multiplied by displacement multiplied by cos theta. Alright, where the cos theta, why you take the cos theta here? I mean, no angle is shown here. So why you are taking, what is the reason for taking theta? Due to the reason that the force is in the opposite direction of the motion or the movement of the object. So then you are required to take the cos theta, where the cos 180 is the angle of a straight line. All right. So just remember these scenarios, very important. Sample 4. Okay. Problem 4. A man pushes a box of mass 5 force of 2 Newton along a horizontal frictionless surface. The box is moved through a distance 3 meter. Calculate the work done on the box by pushing force, normal contact force and weight of the object. Okay, normal contact force is the force perpendicular to the object. All right, or what we can say is yes, it is perpendicular to the objects. And the pushing force. Okay, so pushing force is shown by F, weight is shown by mg, and normal contact force is shown by N, which has discovered 3 meter distance. Now for A, what you'll be doing is that work done. Work done is equals to force multiplied by displacement cos theta. Alright. And here you can that 2 multiplied by 3 is equals to 6. Okay. Cos theta. 3 is the displacement, and what is 2 here? 2 is the force which is given in the question. I did not mention in the diagram. I was just focusing on the diagram. Why? So I do not know. Okay, so force multiplied by displacement, and there is no interference of theta, cos theta. So the answer is simple 6 joules. All right. So for B, W is 0 joule. The normal contact force is 0. Force perpendicular to the displacement. All right. It means that there is no normal contact force, and it is 0 obviously. And the weight of the object, which is mg, is 0. Means the work done is 0 due to the reason that the object is not moving downwards, neither it's moving upwards. It's moving to the right side. It means that the pushing force is obviously having any particular work done, which is 6 joule. Other than that, normal contact has means what can we talk about normal contact force when the object is moving to the right side, or either if it's moving to the left side. It's neither moving upper nor moving down. So there is no interference of weight or the normal contact force. So the work done is 0 for them. Understand? Example 5, solve it. Okay. A block is pulled along a rough horizontal surface by a rope pointing at 60 degrees above the horizontal. Okay. Rough, what does rough means? It means it is frictionless, frictionless. Rough means frictionless. Okay. Means no friction. The tension in the rope is 10 Newton, okay? And the frictional force is 5 Newton. The block moves a distance of 2 meters along a surface. Calculate the work done on the box by tension in the rope and frictional force. Again, you will be applying the work done is equals to Fs cos theta, and just see this diagram where the object is having a certain displacement of 2 meter, having the frictional force of 5. Am I? Yes, I am right. And 10 Newton is a tension force. Okay, this is a tensile force, and also the angle is also given to you, so you're required to just insert the values as simple, and you'll be getting 10 joules for A, which is the tension. It's not necessary for you to just apply the okay. For the frictional force, again, negative 5 multiplied by 2, right? Now one more thing is in negative. Because of only reason the frictional force is opposing the object's movement, it means that it must be in the negative direction. All right. Example 6, solve it. How much work is done by a person who uses a force of 27.5 Newton to move a trolley of 12.3 meter? As you can see that this is one of the easiest question. Like force is given to you, displacement is given to you, and just simply apply the formula. W is equals to FD. All right. Now this is a special case. Let's suppose a force F is acting on an object along the x direction, and the object moves a distance x2 minus x1 along the same direction. Alright, it means that this is the object, x1 and x2 are the distance. Alright, and the arrow shows the force F. Understand? All right, so the displacement is written as x. Okay, if F is constant or the force is constant, so the work done is given by F is equals to, sorry, W is equals to F, and then bracket open as x2 minus x1 means the range of x or the change in the distance. Yeah, that's very easier. Okay, and this is the diagram. This, sorry, not the diagram. This is the graph. From this graph, you can see the graph of force against the not extension. This is the force again. Means x is obviously for the extension. You'll be learning this in the upcoming chapters. But this x is representing the distance or the displacement. So the work done is equals to area under force displacement graph. So what I'm trying to say is that the area, or what you can see from this figure, from this graph of, on the y-axis there is a force and on the x-axis there is the distance. So you can see that x1 and x2 values are visible to you, and what is the force which is visible to you at the straight line and the dotted line which are showing the displacement. So the force displacement graph, so the area under this force displacement graph shows you the work done, due to the work done is equals to force multiplied by displacement. All right. So whatever, what means, in whatever shape or whatever the values are given to you, or whatever the graph or whatever the best fit line or the smooth curve is shown to you in your graph of force against the displacement graph, so you are required to just memorize that this the area under the graph is called work done. Because of only just a reason that the work done is equals to force multiplied by displacement. All right. So this will be learning. Take care. I hope so that you understand this, and these are the very important scenarios. All right. So see you in the next video. Till that, goodbye.